Today we're going to talk about angles and how we can graph an angle. And then we're going to talk about something called radians. An angle in geometry has two sides. It has one side that we're going to call the initial side, which is a ray. We learned in geometry that a ray has a point at one end and it goes on forever at the other end. And then it has what's called a terminal side. And basically what we do is we say we're going to start with those two rays laying right on top of each other, and then we're going to kind of open up the hinge, and that will make an angle. When we graph our angles for trigonometry, we're going to do so in what's called standard position. An angle graphed in standard position means that on an x and y axis, one side of our angle is always going to be the positive x-axis, pointing straight out to the right-hand side.
Wait, what one is this?
Standard for standard position. Yeah. One of those sides of our angle is always going to be the positive x-axis. And then the other side could be anywhere throughout the rest of the region. Just put it over here. And now, as a little side note, I'd like you to draw a few small circles. Just in the margin of your paper, doesn't matter how many, doesn't matter how big, just doodle a few circles.
Do they need to be like far apart?
No. This is just doodling. Like, just don't stress it, just circles. That's all I need is circles. And then I want to know, how many of you, by a show of hands, when you draw a circle, do so in a counterclockwise direction?
That's kind of, yes.
This is the other way.
Most
Can't really do it
people,
very well.
and it doesn't even seem to be a right hand, left hand thing, or like a right brain, left brain thing, just most people draw circles in a counterclockwise direction. I don't know exactly why it is, but most people do. Conveniently, when we graph angles, we are going to graph our angles in a counterclockwise direction. So if this positive x-axis is our starting side, then we're going to draw in a little arc that shows which way we opened up the hinge. And in standard position, we're going to open up that hinge in a counterclockwise direction. Okay. So then going around, we would say if we didn't open up the hinge at all, that would be like a 0-degree angle. If we open it up a quarter of the way, that would be a 90-degree angle. Open it up halfway would be 180. Open it up 3/4 the way around would be 270. We could open it all the way up as 360, or we could actually keep on going around too and even do more than 360. We could also open it up in a backwards direction as well, but then we're going to draw that arrow to show which way we opened it up. So that's our first type of problem. It's just graphing some angles. So to graph 210 degrees, I need an x and y axis. Our starting side is always the positive x-axis. And then I want to open up the hinge 210 degrees. So I just said if I opened it up halfway, that would be 180. I want to do more than that. How much more than that? 30. So our final picture should show our starting side, our initial ray, the positive x-axis. It should show our ending side. It should have the arc of the arrow that shows which direction we opened up the hinge, which will be counterclockwise for positive angles. And we want this little 30 in there that gives some reference because you're not actually using a protractor. So this isn't perfectly 210 degrees. So we want that little 30 in there so that somebody looking at your paper knows how big you meant it to be, even though it's not going to be perfect. Okay, we don't need to use protractors. We can just put that little 30 in there. When you place this number, some students want to put like a 60 down in the other section and say that it's 60 degrees less than making that next point. We always want to place this number next to the horizontal. Okay? It should always be next to our horizontal marker, not next to the vertical marker. It doesn't matter for today really, but since I know where we're going in the next lesson, it will matter then. So get in the habit of always placing that number value of how big the angle is next to the closest horizontal line. So then for negative 45, to graph a negative angle, we are still going to start in the same position. We are always going to start at the positive x-axis. But to graph a negative angle, we're going to go backwards. So I'm going to go clockwise 45 degrees. And then I'll put in there a 45. That shows that's how big I need that to be. We draw the little arrow that shows that I opened this one up backwards. And for our last one, 510, we're going to start at the positive x-axis. If I go around one full circle, I've covered how much? 360. And that's not enough yet. So then I need to see how much more do I need to do. How do I find that out?
360. Is it 510 minus 360?
Subtraction. 510 minus 360 leaves 150 more left over to do. So right about to here. And remember, we always want to put our number indicator next to the closest x-axis. So 150 is 30 less than making it to that 180 line. So in this one, we need our starting side, our ending side. We need our arrow that shows what way we went and that we went a full circle before going the remaining amount. So we can draw in spirals. Sometimes you'll have multiple spirals if we have to do a couple or a few full circles before we get around to being able to measure our angle. Questions on graphing angles?
It works.
Go ahead and graph these three angles. Okay, for negative 120, we always start at the positive x-axis. Negative tells me that I'm going to go around in a clockwise direction. I'm going to go around 120 degrees, which is less than half of a circle, by 60 degrees. Okay, so again, we want to think about that it's 60 less than the 180 instead of thinking that it's 30 more than the 90. It is 30 more than 90, but for where we're heading with tomorrow's lesson, you always want to put that number indicator of how big the angle is next to the closest horizontal line instead of the vertical line. 400, I'm going to start at the positive x-axis. Since it's a positive 400, I'm going to go around in a counterclockwise direction. One full circle takes me 360, and then I need to go 40 more than that. For the last one, 350, I'm going to start at my positive x-axis. It's a positive 350, so I'm going to go around counterclockwise almost one whole circle. So I'm just going to have a little sliver left, and I'll put a 10 inside of there. Okay. To introduce our next idea, our next type of problem, I want to take a look at this middle example here. If I had not drawn that spiral and arrows in there, so if that stuff isn't there, and all you see is that there's an angle that's supposed to be 40. You do not know whether the angle that I graphed was 40 degrees. Maybe it was just 40 degrees. Or maybe I went around one time and then 40 degrees, 400, which is what we actually did. Or maybe I went around twice and then another 40 degrees. Or maybe I had gone around backwards and it was negative 320. If I don't draw that arrow and spiral in there, you have no idea what angle I actually intended to graph. You just know where it ended. Okay? And all those angles end in the same place. We call these coterminal angles. Co means together or with, terminal means ending. So there are angles that end in the same place. Okay? So 40 ends in the same place as 400 because they're 360 degrees away from each other. Ends in the same place as negative 320. They all end in the same place if we graph them out. the easiest way to find a coterminal angle is to know that they happen once per circle. Okay, wherever that is, I'd have to go around another full circle to get back to that place. How big is a circle? 360. So the easiest way to find coterminals is to add and subtract 360 to the number that you're given, and that'll give you coterminals. You can add and subtract 360 as many times as you want, and all of those angles will be coterminal. On your assignment, you will be asked to give one positive and one negative coterminal angle for the given angle. I'm going to ask that you give the closest positive and negative answers to it because that's going to make grading easier. But technically, you could add 15 360s if you wanted to do that. Okay, but that's not going to be the answer that I give when I read the answers tomorrow. So we're just going to stay to our closest positive and negative answers. So for negative 60, I could add 360 degrees and get 300. Graphing negative 60 and graphing 300 would look exactly the same except for the direction of that spiral arrow. You don't have to graph them, you just have to find them. You'll be asked to give one positive and one negative. So to find the negative, I would take negative 60 and subtract 360 from it. And that gives me negative 420, which would look exactly the same as 300 and exactly the same as negative 60. To find coterminal angles, we want to add and subtract 360 degrees. For 495, I could add 360 to that, and that's totally fine. I'm going to start by, though, subtracting 360, which leaves me with 135, which is still positive. So if you're asked to give one positive and one negative angle, I have a positive one. To get a negative one, I'm going to subtract again, because you can add and subtract as many times as you want, and the goal is one positive answer and one negative answer. So if my starting angle is already bigger than 360, I'm going to need to subtract more than once. So when I subtract again, I don't know.
Negative 235.
Negative 235? That doesn't sound right.
No.
225? 245? I don't know. You might be right.
Something like that.
225. Okay, so the goal is one positive and one negative answer, and we find them by adding and subtracting 360s as many times as necessary to get those. Questions? Those are called coterminal because if we graph them, they would end in the same place. So terminal means end and co means together or with. Go ahead and find them for these two angles. Okay, so for negative 100, I can add 360, and that gets me to 260. Or I can subtract 360, and that would get me to negative 460. So I have one positive and one negative answer. For 575, I can subtract 360. I could also start by adding, and that would be a totally fine thing to do. That'll give you a positive answer. But subtracting also gives you a positive answer. And you need a positive and a negative. So I'm going to start by subtracting, and then I'm going to subtract again. So I get one positive and one negative answer. Questions? Okay, one more thing to talk about today is the idea of what a radian is. A radian is just another way to measure angles. So typically we measure our angles in degrees. We talk about 180 degrees in a triangle or 360 degrees in a circle. We typically measure angles in degrees up to this point. But in trigonometry, we are usually more concerned with measuring angles in something called radians. It's just a different unit. Just like if I'm measuring how long this room is, I could measure it in inches, I could measure it in feet, I could measure it in centimeters. There's a lot of different units of length that we can use to measure things. If we're measuring a temperature, we could use Fahrenheit or Celsius. There's different ways to measure that. There's two different main ways to measure angles, and those are degrees and radians. So degrees we're already pretty familiar with. Radians maybe not so much. Radian sounds a lot like the word radius, and it sounds that way because it is related to that. So if I have a circle and I draw in a radius of length 1, we could think about this as being like an angle and say that's the starting side of our angle, and open up our hinge and say how much of this circle have we traced out? Like if there was a marker at the end of that, how much of this circle has been traced out? So we need to say, well, how big is the whole circle? So if I'm talking about the edge of a circle, what do we call that? Circumference. What is the formula for circumference of a circle?
Like the perimeter of the circle? Is that what you're asking?
Yep. The formula for circumference of a circle.
Something with pi in it.
Something with pi.
Pi r squared.
Pi r squared is area.
2 pi r.
2 pi r is circumference.
There we go.
So if I'm going to say that I have a radius of 1, then the circumference of our general circle would be equal to 2 pi. So opening it up all the way would give me a full circle. We're going to say a full circle is 2 pi radians. And then we could just portion it down by that and say how much of that did we open up. So our conversion then to move back and forth between radians and degrees is going to be that a full circle, 360 degrees, is equal to 2 pi radians. Since both of those numbers are even, we're going to reduce this down to make our problems work out a little bit cleaner and say that 180 is equal to pi radians. This is a conversion just like there's 12 inches in 1 foot, or 2.58 centimeters in 1 inch, okay? 5,280 feet in 1 mile. It's just a way of moving back and forth between the two units, okay? So that 360 degrees is exactly equal to 2 pi radians.
So would 90 be half pi?
So 90 would be half of a pi. So we can use these to then switch back and forth between units. So if we have 110 radians, or sorry, 110 degrees, and we want to switch that into radians, we are always going to use 180 and pi. We're going to set it up as a fraction, and I always put what I'm given on the bottom. That's what I label first, so I can make sure that I cancel. You will always be using 180 and pi, and you just need to decide which one's going to go on top and which one's going to go on bottom. You want to set it up so that what you're given cancels. So since I was given degrees, I'm going to put degrees in the bottom so that they cancel each other out. Then we're going to multiply, except we're not going to type this in our calculator and get a big ugly decimal, because that's what we would get for a pi. We're just going to multiply it straight across and then reduce. So this becomes 11 pi over 18. To convert radians, so in the second example, we're given negative pi over 9. Again, we're going to set up a fraction of 180 and pi. And we want to set it up so that what we're given cancels. So I'm going to put the pi on the bottom so it cancels, which puts the 180 on top. So pi's go, and I multiply across, and I get negative 180 divided by 9, or negative 20 degrees. You will always use 180 and pi, set it up so that what is on the bottom of that conversion cancels what was given in the problem. Questions? Try these last two. Okay, so for the first one, I've got 320, and that's degrees. So I'm going to put my degrees on the bottom, which puts the pi on the top. And when I multiply, that gives me 320 pi over 180. And I want to reduce that down, which will give 16 pi over 9. Leave it as an improper fraction, so don't divide out the 16 and 9, but reduce down that fraction as much as possible. And then the pi just kind of hangs out in the top of that fraction. For converting negative 5 pi over 12, I'm going to want to put pi on the bottom so that it cancels the pi that's there. Then I need to multiply 5 times 180, and I get negative 900 over 12, and divide by 12 gives me negative 75 degrees. Multiply across the top of the fractions and then divide by whatever's on the bottom of the fractions. Questions? All right, that is lesson 2 from the assignment.